Construction of airport runway. Designing and constructing a civilian aircraft runway involves multiple considerations, including regulatory standards, environmental factors, and engineering principles. Here's a detailed breakdown of the contents typically involved in such a project. Joy contents of runway design and construction. A. Regulatory framework. International standards. Adherence to ICAO, International Civil Aviation Organization, guidelines. National regulations. Compliance with local aviation authorities, e.g. FAA in the U.S. B. A wind study for airport runways typically involves analyzing wind patterns, speeds, and directions to optimize runway orientation and operations. Here are the key components. B11. Wind data collection. Use anemometers and wind vanes to gather data on wind speed and direction over a significant period, usually a year. Consider seasonal variations in wind patterns. B2. Analysis of wind patterns. Identify prevailing winds, most frequent direction and speed. Assess crosswinds and tailwinds that could affect takeoff and landing. Through BC, runway orientation. Position runways to minimize the impact of crosswinds and maximize headwinds during takeoff and landing. Use the wind rose diagram to visualize wind data and determine optimal runway alignment. B4. Safety considerations. Evaluate the impact of wind on aircraft performance, especially during adverse weather conditions. Implement design features like barriers or vegetation to mitigate wind effects on approach paths. B5. Regulatory compliance. Ensure the study adheres to guidelines set by aviation authorities, e.g. FAA, ICAO. Dream recommendations. Propose changes in runway usage based on wind data. Suggest potential new runway designs or configurations to improve safety and efficiency. C. Site selection. C.1. Location analysis. Proximity to airports, urban areas, and geographic considerations. C.2. Environmental impact assessment. Evaluation of potential effects on local ecosystems, noise pollution, and wildlife. D. Runway design. D1. Dimensions, length, width, and thickness based on aircraft types and expected traffic. D2. Orientation, wind patterns and prevailing weather conditions affecting runway alignment. D3. Load-bearing capacity. Assessment for different aircraft weights and types. D4. Cross-section design. Drainage systems, shoulders, and safety areas. Durability materials selection. E1. Pavement types. Asphalt versus concrete, considering durability and maintenance. E2. Subgrade materials. Soil testing and stabilization methods to ensure a strong base.
F. Construction techniques. F1. Excavation and grading. Preparing the site by removing vegetation and leveling the ground. F2. Pavement construction. Techniques for laying asphalt or concrete, including curing times and temperature controls. F3. Drainage systems. Installation of surface and subsurface drainage to prevent water accumulation.
GC safety features. G1. Runway safety areas, RSA. Clear zones at both ends of the runway to enhance safety. G2. Lighting systems. Installation of runway edge lights, approach lights, and visual aids. G3. Markings and signage. Standardized markings for runway identification and taxiing. G3. Quality control and testing. H1. Material testing. Ensuring materials meet specified standards. H2. Construction inspections. Regular checks during construction to adhere to design specifications. Studio maintenance planning. I1. Regular inspections. Schedule for visual checks and structural assessments. I2. Repair protocols. Guidelines for addressing wear and damage. 2. Design considerations. A. Aerodynamic considerations. Ensuring runway design supports safe takeoff and landing dynamics. B. Geographical factors. Tailoring design to local geography, such as mountains, valleys, or water bodies. C. Climate resilience. Designing to withstand local weather extremes, including snow, rain, and heat. 3. Construction process. 3.1. Pre-construction phase. A. Planning and permitting. Securing necessary permits and conducting stakeholder consultations. B. Surveying. Detailed site surveys to assess topography and soil conditions. The construction phase. B1. Site preparation. Clearing, grubbing, and excavation to create a stable foundation. B2. Base layer installation. Laying down the sub-base and base layers using appropriate materials. Surface layer application. Applying asphalt or concrete to create the runway surface. B4. Finishing touches. Installing lighting, signage, and markings.
3. Post-construction phase. 3.1. Final inspections. Comprehensive assessments to ensure compliance with standards. 3.2. Operational readiness tests. Conducting test runs with aircraft to assess functionality. 4. Environmental considerations. 4.1. Noise mitigation. Implementing measures to minimize noise pollution for surrounding communities. 4.2. Wildlife management. Strategies to prevent wildlife hazards in and around the runway area. 4.3. Sustainability practices. Using eco-friendly materials and practices during construction and maintenance.
Subscribe, share,